All right, here we go. Oops. Let's get the mic on here. There we go. All right, this should not take that long. It's got a few theorems. 1, 2, 3, 4 different theorems. Let me see. Yep. Then a couple examples. Did anybody actually watch the video this weekend? Just 2? You didn't watch it? No? No? All right. Well, the assignment was to watch it. That's good. All right, so now it says proofs of parallelograms. We're not really proving anything. I'm not really sure why they call it proofs of parallelograms. I guess what they're doing is they're giving you a situation and they're asking you, is this thing a parallelogram? Okay? Whereas before, they told you what? What was the given? They always told you what? That it was a parallelogram, right? So before, I guess, was it 6.2 where we did parallelograms? Probably was, wasn't it? Yeah. Because 6.1 was like an overall view of different quadrilaterals. So 6.2 was just about parallelograms, but they always told you it was a parallelogram. And then you knew a lot of stuff about it, correct? So if you knew it's a parallelogram, you knew the opposite sides were equal, you know the opposite angles are equal, you know the angles the diagonals bisected each other. You knew all that stuff. Why? Because it was a parallelogram, and I gave you a whole bunch of information about it being a parallelogram. This time, we don't know it's a parallelogram, but they give you information about it, and we have to be able to look at it and say, oh, yes, that is a parallelogram. Do you see the difference? So in the other lesson, they told you it was a parallelogram, you knew a whole bunch of stuff about it. This time, they tell you a few things about a quadrilateral, and you have to be able to determine, is this a parallelogram or not? Okay? So that's basically what we're doing. So let me draw. Well, I'm not going to draw. I'll use this little thing to draw a parallelogram. Usually we put a little slant. I mean, technically that is a parallelogram. Would you agree? But we usually make it look something like that. All right? Oops. All right, so here's your basic everyday looking parallelogram that you see in books and all that kind of stuff. All right, here's what they give you. Remember, we don't know it's a parallelogram. Well, I said it was a parallelogram. I said I was going to draw a parallelogram. But right now, just looking at it, with the information that you have right in front of you, can you tell that that's a parallelogram? Why is it a parallelogram? Because it looks like one. How long have you been in this class? Is that what we do? Just because it looks like it? No, come on. That's why they call it proofs of parallelograms. You have to be able to tell me, why is it a parallelogram? And because it looks like it is not a reason. It's not a valid reason. Somebody else, give me a reason why this is a parallelogram. Because I said it was when I first drew it, maybe. Okay, probably. But just looking at it, with the information you have right now, actually, do you have any information? You got a little bit. You know it's a what? You absolutely know 100% it's a what? A quadrilateral, because there's 4 sides. Okay, everybody got that? But can you tell me that it's a parallelogram right now with the information that's given? No. You might be able to look at it and say, well, the opposite sides look parallel to each other, but do I know they're parallel to each other? No. It's not written in there. You look at it and say, well, the opposite sides look like they're equal to each other, but does that mean they are equal to each other just because it looks like they're equal? No. You have to be told, and that's what we're going to do right now. So here's what's given. This is what's given. It's not given. I'm going to say this a lot, okay? You'll probably get tired of hearing it, and I'll probably get tired of saying it. But this is the difference between this lesson and 6.2, all right? 6.2, they told you it was a parallelogram. This one, you just look at it, at the information they give you, and you have to be able to tell if it's a parallelogram or not. So if they just gave you those 2 sides equal to each other, is that enough to say it's a parallelogram? It's not. Just one pair of opposite sides equal is not enough. But if they tell you that both pairs of opposite sides are equal to each other in length, that right there is enough to say it's a parallelogram. So, is this a parallelogram with this information now? Yes, it is a parallelogram. All right? And that's a theorem. In my notes, I have it all written out, and in the book it's written out. But it basically, this theorem says A quadrilateral is a parallelogram if what? If both pairs of opposite sides are equal or congruent. Okay? Do we have both pairs of opposite sides equal? Do we have a quadrilateral? Yes. If all that stuff is true, then guess what this thing is? It's a what? It's a parallelogram. Okay? Do you understand what we're trying to say here? Oops, let's copy this. All right, let's move on. So, if you want to write your notes, say if both pairs of opposite sides are equal, then it's a parallelogram. That's your if-then statement. All right, we have a lot of if-then statements. So, if it's a quadrilateral and both pairs of opposite sides are congruent, then it's a parallelogram. All right, let's do another. These are all theorems. I'm not going to write this down. I'm not going to write the word theorem down every single time. All I'm going to do basically is just draw the pictures. And I'll draw all separate pictures instead of just using the one. All right. Let's use the same color. Now, this one's a little different. Actually, they don't have this. I'm going to add a fifth one in here. They don't have it, but what if they told you that this and this were parallel? Okay, so one pair of opposite sides are parallel. Is that enough to say it's a parallelogram? Just one pair of opposite sides? No. Okay, that's enough to say it's a what? Trapezoid. Remember that? Okay, but it's not enough to say it's a parallelogram. But if I do this, this is not really a theorem. This tells me it's parallel because of the definition of a parallelogram. The definition of a parallelogram says that it has two pairs of parallel sides. Okay, that's not really in the theorems that they list right here. I just threw that in there free of charge. Okay, all right, everybody see that? So if you have a situation like this, can I look at this and say this is a parallelogram? Sure. Okay, and it's because of the definition of a parallelogram. It's not because of any theorem. All right. All right, let's do another one. Let's get that color. All right, here's a situation. We've already said this before, but let's say it again. Is that enough to say that that's a parallelogram? No. But here's something new. All right, this is the new part, basically, of parallelograms. If you know, and this is a theorem, it can be proven. We're not going to prove it, though. But it can be proven if you know that one pair of opposite sides are both equal and parallel. You just know that one pair of opposite sides. You don't know anything about this side and this side right here. You know nothing about it, okay? But you do know that the top one and the bottom one are both equal to each other and parallel to each other. That means that this thing is a parallelogram. Everybody understand that? All right, so if this side is equal to this side, and the same exact side is parallel to the other side, then it's a parallelogram. Okay? You don't have to know anything about this side and this side. All right, so that's kind of interesting. Let's do another one that are pretty familiar to us. And that's this one's going to deal with the angles. Now, if it was a parallelogram, what do we know about the opposite angles? They're equal to each other. They're congruent to each other, okay? If it was a parallelogram, okay? Do I know this is a parallelogram right now? No, because I haven't been told anything about it. But what if I was told that this and this were equal? Is that enough to say it's a parallelogram? Not yet. What else do I have to show? That the other two opposite angles are equal to each other or congruent to each other. All right, if I know that both pairs, if you want to write it down, you can, it's in the book. You know this is a parallelogram if both pairs of opposite angles are equal. I don't have to know anything about the sides at all, okay? I don't know that that side is equal to this one. I don't know that this is equal to this. I don't know that these two are parallel. I don't know that these two are parallel. The only thing I know is that the opposite angles are equal to each other. That's enough. That's enough information for us to say that this thing is a parallelogram. Everybody with me? Yes? No? Maybe? All right, let's do another one. This will be the last one. And then we'll do a example. All right, let's do this. Let's draw a line from that corner to that corner. What do we call that? We have a name for that. It's a diagonal. Very good. All right, so we have two diagonals and they intersect each other. Now, if it was a parallelogram, you would know, because you had this on a quiz, didn't you? You would know that these diagonals do what to each other? They bisect each other, exactly right. But we don't know it's a parallelogram. But if I told you that this little segment and that little segment were equal to each other, and that's not enough, okay? They have to bisect each other. So this one is being bisected because it's split into two equal parts. This one is being bisected because it's split up into two equal parts. Is that enough to say that this is a parallelogram? Yes, it is, okay? So if I know that that's true, if I know that the diagonals bisect each other on a quadrilateral, then that thing is definitely a parallelogram. Now, since I know it's a parallelogram, now what can I say about the top and bottom? They're equal and they're parallel, right? What can I say about this left and right side? They're equal and they're parallel, okay? But I didn't know that. It was not given to me at the beginning. This is the only thing that they gave us. Okay, that's enough information in order to say that that thing's a parallelogram. We good? All right. Here's another one that they didn't say, but they could. I'm not sure why they don't make this a theorem. It seems like they should. But what if I told you that this angle and this angle were supplementary? What if I told you that angle A and angle B, we'll call this C and D. What if I told you that A and B are supplementary? They add up to 180. Is that enough information to say that this is a parallelogram? It should be, shouldn't it?
Yeah, it is.
Right? If these two are not equal, if they add up to 180, okay? I'm trying to think. It feels like I'm making up my own theorem, so I don't know if I should go any further than that. But because the thing that's making me pause a little bit is you'd think that they would put that in one of our theorems, wouldn't you? But I don't think that's in there. So let's skip that. I'd have to look that up, okay? Listen to smarter people than myself. The reason I said that is because of example 1, 1A more specifically. Let's make this a little smaller. Come on, grab it. Why can't I grab that thing? There we go. Whew. It's a lot harder than it looks. Let's tilt this a little bit, make it look a little bit more like the example. Kind of looks like that. Doesn't look quite as slanted, at least in my notes. All right, here is, I'm just going by my notes. I'm not going by my theorems. Did I cover everything? Angela, you got your book in front of you? Did I cover all the theorems? There's not another theorem that talks about being supplementary, is there? Okay, I didn't think so. But on 1A, I actually used that. Oh, okay. I know why. Okay, I see it now. Maybe because it's my sickness. I'm not thinking very clearly. I'll blame it on that, okay? Not on just me being dumb, but let's change that to that color. And this is 108, 108, and this is what? 72. All right, this is the information. So this is what they give you. What are we trying to do? We're trying to be able to say, is this thing right here a parallelogram? Well, I got both pairs of opposite sides equal to each other. Is that enough right in and of itself? Just having one pair of opposite sides equal? No. Is there any way in this situation that I could show that DE and GF are equal to each other? There's really not. Okay, there's no way I could do that. But why'd they give you this? Why'd they give you 108 and 72? Well, what's true about 108 and 72? They're supplementary. They add up to 180. Exactly. Now, what does that mean, though? So if this and this are supplementary, look at this. This is our transversal, and these would be what kind of lines? They would be parallel lines. Remember that? Consecutive interior angles? If the consecutive interior angles are supplementary, then what's true about the two lines that are cut by that transversal? They're parallel to each other. You see that? So they would be parallel. So now we have a situation where you have one pair of opposite sides, both being what? Equal and parallel. Is this a parallelogram? Yes, it is. Yes. Okay, it's a parallelogram. All right? So that's the kind of stuff they're going to ask you to do. All right, let's do another one. This one looks more rectangular-ish. All right, what do they tell you here? They tell you that this and this are equal. I should have done that in pink. Let's do it in pink. Just keep that color scheme going. All right, and then, thought I changed it. There we go. Okay, I think I have to click off of it. It's weird. All right, let's try this again. So now it should be pink. There we go. All right, with that information, it's the only thing we know about this. Okay? Just because this has one arc and that has two arc does not mean that they're supplementary. Let me say that. Everybody understand that? Okay, just means that they are not equal to each other. Got it? Now, it looks like a rectangle. It looks like they should be equal to each other. Would you agree? But maybe it's like 89.99999 degrees. All right, so it kind of looks like a rectangle, but it might not be. But this is the information they give you. Again, don't just go by it looks like a rectangle, so it's a parallelogram. Can I say that this is a parallelogram or not? So yes or no? What do you think? Why not? That's right. The only thing you know about this thing are the angles, correct? And so how do I know if a quadrilateral is a parallelogram? Only if the opposite angles are equal to each other. Are the opposite angles equal to each other right here? No, the consecutive angles are equal to each other, but that does not mean that this is going to be a parallelogram. All right? Everybody see that? Because this side right here could slant in like that, couldn't it? This one could slant in like that, and those two are equal and these two are equal. It doesn't mean it's a parallelogram. All right? So, what's our answer for this? No. Okay? We cannot say that it's a parallelogram. All right, let's do another one. I'm just going to copy and paste that one. Come on, grab it. There we go. Now check this out. That's a right angle, and that's a right angle. And that is the only thing that we know about this. Is this a parallelogram? Well, we know the right angle, so we do know that this and this are parallel, correct? Because that would be our transversal, right? And those, because since they're supplementary to each other, right? They're consecutive interior angles. They're both 90, so they add up to 180, all right? So they would be parallel, but does that mean that this is a right angle and that's a right angle as well? No, because I could if I wanted to, right? We'll just use the same. What if I extended that side and I went like this? Okay, forget that one in the inside now. Do you see that? See, I could extend this. These two are still equal to each other, but is that whole thing a parallelogram? No, it's not. So we just kind of showed right there that it's not a parallelogram. So we say no. That would not be a parallelogram. We good? Okay. Enough of that. One more example and we'll be done. This is the kind of stuff you're going to want to be able to do, because this is where you're going to use a little bit of math, do some geometry, just like we've always done. Let's go like 20 degrees this time. All right. Let's put some diagonals in here. Right there. Right there. And we'll call it Q, R, S, and P. T is in the middle. That's where they intersect each other. And then they told you that this segment right there is 5A. See how they put it right on top of it? That means QT is 5A. And then TS is 20. So we'll put that there. TR is 7B minus 4. 7B minus 4. And then PT is 6B plus 2. 6B plus 2. And what I want to do is I want to be able to solve, okay, for A and B. Now, here's what the question says. Now, right now, I don't really know that this is a parallelogram because they didn't tell me it was a parallelogram. But here's how they word the question. It's it's kind of like what we did on section 6.2 with a slight difference, okay? It says find the value for each variable that ensures that that quadrilateral will be a parallelogram. Okay, do you hear the difference in the wording? In 6.2, they would say, it's given that this is a parallelogram, solve for A and B. This one says, find A and B, right, that ensures that this thing is a parallelogram. It's a subtle difference. It's one that you probably don't care about that much because the math is exactly the same, right? It really does not change. So, how do I know if this, or how could I tell if this was a parallelogram? Well, if the diagonals do what? Bisect each other, then this thing would be a parallelogram. So what does A have to be and what does B have to be in order for this thing to be a parallelogram? That's kind of what they're asking. We good? So what would I do with the A? What would I do with that? That's it. 5A equals 20. Because remember, the diagonals should bisect each other if this was to be a parallelogram. So this and this would be equal. So I set them equal to each other. What else do I know are equal? Yep, 6B plus 2. I'll tell you what, just to make the algebra just a little bit easier, I'm going to put the bigger number first. Is that all right? So 7B minus 4 should equal what? 6B plus 2. And now all I got to do is solve for A and B. Very simple. There's not even any substitution or anything like that. It's very, very basic. So, right, divide by 5. So A is 4. All right, so that's that. And then what do I do here? Subtract a 6B. That'll give me a B. Add a 4. That'll give me what? 6. And there you go. And they just say find the value for the variables. They don't even ask you to find how long the sides are. That would be pretty easy for A, wouldn't it? Okay. Like, what would QT be equal to without doing any math whatsoever? Without doing any math, what would line segment QT be equal to? Give me a number. What is QT equal to? 20, right, because it's bisected, right? This segment from here to here is equal to this segment from there to there. I already know this is 20, so without doing any math whatsoever, I know QT is 20. Now, PT and RT, I'm going to have to plug it in. I can't just look at it and tell. But you could do it if you wanted to, couldn't you? Put a 6 in for B. Let's put it in for this. 6 times 6 is 36 plus 2 is 38. Now, again, it's not drawn to scale, obviously. All right? That's 38 and that's 20. This should be a lot longer looking, but it doesn't have to be to scale. All right? Okay, enough of that. Let's do one more. That was part A. This is part B. We'll do one more like this. Let's grab this. All right, and let me, oops, didn't want to do that. I want to do this. Just so it looks a little bit more like what I have in my notes. All right, let's mark this up. A, B, C, D this way. So A, B, C, D. And I never used the orange. Let's use the orange. So this is 2x. This time they're not dealing with the angles. They're dealing with the sides, correct? Now this is one of those ones we're going to have to do a little substitution, which is not that big of a deal. We did it the other day. It's pretty easy. Hunter, you getting all this? So again, what are we trying to do? All right, it says find each variable that ensures that this quadrilateral is a parallelogram. So I want to find what should x be equal to and what should y be equal to in order to make this a parallelogram, right? So we know sides. So what do we know about the sides? What has to be true about the sides in order for this to be a parallelogram? The opposite sides need to be equal to each other. So if I set this equal to this and this equal to this, that would ensure that it's a parallelogram. And then I just do some math, some algebra, and solve for it. So let's do it. So 2x equals what? Y plus 14. Oops. All right, and let's do the other one. Let's do the x first. X plus 11 must equal what? Y. And now it's just a matter, my geometry's finished, okay? Now it's just a matter of doing some algebra. But I've got two different variables, correct? Look at this equation. That has an x and that has a y in it. So I need another equation. Remember that? If I have two variables, I need to have what? Two equations. Now, could I have solved for a without this second equation here? Yeah, because I only had one variable in that equation. You with me? This one, I only have one variable in that equation. All right, so they're not dependent on each other, are they? All right, but right here, they are dependent on each other. So how would you do this? Well, I would do this. Since y is equal to x plus 11, what am I going to do with that y? So this y and this y are the same number. This x and this x are the same number, okay? So if y is equal to x plus 11, I'm going to take that x plus 11 and substitute it in for that y. Right? We did it the other day for the first time. So it's 2x equals, instead of y plus 14, what is it going to be? X plus 11. You had this on the quiz too, didn't you? Did you have to do a substitution one on the quiz? I can't remember. I think you did. All right, so there's your y, what? Plus 14, right? And now look, I've got one equation and I've got one variable, and now I can solve for x. All right, so let's do that pretty easily. Subtract x from both sides, I get x. Add the 11 and 14, I get 25. So that's my x. Now I just have to solve for y. So I'm going to do one little substitution. So y is equal to what? X plus 11. Well, I just found x. That's 25 plus 11. So what's y equal to? 36. It's as easy as that. The geometry was the easiest part, wasn't it? And you probably already have found out up to this point, the geometry usually is the easiest part. All right, it's just knowing what to set equal to each other, right? And then once I'm able to do that, and then it's just working algebra, and then I'm done. Would you agree that that's what geometry basically has boiled down to? Yeah, you learn all these things about shapes, right? What angles are equal, what sides are equal, and all that kind of stuff, the relationships between them. And then you basically just set stuff equal to each other, or you add stuff up and set it equal to something else, right? And then you just do some algebra. And that's what geometry, high school geometry, boils down to for the most part. Everybody good? All right. So let's see. What did I give you? 18 to 25. I have a feeling that some of you guys have already finished it. Who's already finished 18 to 25? Good. So I'll collect that tomorrow, okay, if you didn't get a chance to finish it. I don't know what page. Let me write the page. 267. So it's page 267, and it's section 6.3. All right, there we go. That's it. Tomorrow we move on to 6.4.